Okay, let us now do some appetizers for how to program in Python and with NLTK for doing some elementary natural language processing tasks. And now here, if this were a real class, now the topic for you would be to discuss with your neighbor which other applications other than we've already discussed so far involving natural language processing come to your mind. And as subtask of this is what does the computer have to do? What information does the computer need to solve this task? And what do you think? How difficult is this task, and which aspect of the task is the most challenging? Now, if you have a neighbor at home with whom you're doing this, then feel free to discuss with your neighbor or with your friend. Otherwise, you can think about this now for yourself. And in the meantime, we will move on. So let's check some challenges for natural language processing. So one big challenge is goes under the name of ambiguity, which means that the same things can have different realizations. So this is what we call ambiguity. And there are different variations of that. For example, in spelling, you could have American spelling versus British spelling. In pronunciation, so the word China in German can be pronounced in, let's say, at least three different manners. The one would be China, the second one would be China, and the third one would be China. If we go on the level of words, summer, winter, semester, is this one word or is this two words? So there's a certain ambiguity here, non-uniqueness, so to speak, how we do this. Then on the level of, let's say, individual words within a sentence, such as he lives in Mulberry Drive versus Dr. Watson left the room. So we have one token, the R and the dot, that can have different realizations depending where in the sentence the token appears. On the level of meaning of words, so you have ambiguity for many words. So, for example, a classical example is the word bank, which can be the building. It can be it can be a physical building. It can also be in German, at least, it can be something where you sit. It can also be the institution of a bank, so the more abstract, rather than being a physical building, it could be a more abstract concept, and it could be related to like river, right? So it could be like the part, like the earthly part that is connected to the river, which is also called bank. And then ambiguity also arises like on the level of the whole sentence, how to interpret the whole sentence. So you could say, call Peter from Munich. This has at least two interpretations. Like Peter could be from Munich, so it could be to call the Peter who comes from Munich, or it could be the call should be from Munich, right? So you call Peter and the call should be from Munich. And the same goes with time flies like an arrow. So the standard interpretation is that time passes away very quickly, and another interpretation would be time flies. This is a special type of fly, something like a small animal that is flying, a time fly. And then like could be a verb. So those flies, they enjoy arrows, which is from a meaning perspective quite unusual, but still the sentence allows those two interpretations. So ambiguity is a big challenge in natural language processing, and one reason that makes natural language processing difficult and hard. So language problems are hard, and most of them do not yet have perfect solutions. So we're like if we develop algorithms that tackle natural language, they are typically still considerably below human performance, and this depends on depends on the difficulty of the task. So for some tasks, such as, let's say, part of speech tagging that we've introduced before, where we should assign word classes to words. Let's say in English, part of speech tagging is almost solved, right? So because it's a rather low level and shallow task, of course, for other languages which are more complex, like German or Latin or something, the difference to human performance is bigger than for English, but still it's mostly a solved task. And the more you go up the ladder, so to speak, the hierarchy in linguistics, the more you go to the top in on the level of meaning representations and proper understanding. Let's say you do a task like argumentation mining. Uh, there's still considerable difference between performance of machines versus performance of humans. Even though we have to admit that in the last few years, with the advent of deep learning, this discrepancy has also become smaller. And that language is difficult and there are difficult tasks. This is, of course, shared by other fields in science, let's say physics, history, or psychology. In the course, some outlook, what we're going to do in the course is we make some simplifying assumptions. So we mostly focus on English. This is certainly a simplifying assumption because, as I've said before, English is only one language and it's a particularly simple language, let's say, like it doesn't have much grammatical or like morphological variation. So if we look at verbs, for example, there are not many cases, different word forms for a verb. So there's typically an S for the third person. There's the ing form, like laughing, and then there's laughs with an S. And that's almost it, right? So, and there are many other languages where you have a lot more complexity. So English is, in a sense, it's a pretty simple language, and it's also not a prototypical language among the world's languages, but still it's like the most prominent, so to speak, the most important language. So we focus mostly on this. And we mostly work with high quality text rather than, let's say, Twitter, where people make spelling mistakes, very ungrammatical sentences, let's say, and other social media, right? So, so in this course, we stay in a laboratory situation, okay? But just keep in mind that if you go to the real world, then things can be more challenging, more difficult. And even though even though language is hard, keep in mind, or you should be aware that NLP now, with all of the deep learning, is still quite, or is already quite powerful. Even though most of that still only relates to our model situation, our laboratory situation, namely English and high quality. Okay, let's take a look into Python. In Python, you can program interactively. So install Python, install a Python console, as will be explained in the practice class. So many of you will already know it. Some of you will not know it. They will learn it there. You can install it on Linux, on Apple, or on on Windows, and then you run the Python interpreter and you type your commands just like in a calculator. So here in this example, we're adding and multiplying. So we do a little bit of calculations, and you'll see that you get the result right away, and you can really explore. And this is really a cool thing to learn the language, the programming language. That's what makes it easy. And also there's Python 2 versus Python 3. So originally there was Python 2 and people were using that. And then in the last few years, Python 3 has become more popular. So there are many differences. And I'm not the person to explain those differences. I mean, on a high level, there's some differences on, for example, on the level of Python 3 is using Unicode, so this makes it easier to work with in natural language processing, I think. And there are some syntax differences, so how you write the print function. And for a more in-depth differentiation, you could look that up on the web. So this is not so important for us in the course, but just to let you know, we're going to use Python 3. Let's look at a code example here. So there's a little bit of code in Java. So if you're familiar with Java versus Python, so let's say what we want to do is we want to check whether a number is smaller than 2, and then we make some printouts. So in Java, it would have like 10 lines of code, and you have to define a public class, and then you have to define the arguments. You have to tell which kind of what kind of types your variables are. So int is an integer, and then you do the print function, etc. You use all those curly brackets. In the end, it amounts up to 10 lines of code. In Python, that is only half of the code, only 5 lines of code, right? And you do it very intuitively. I equals 1, you set the variable to 1, you check whether I is smaller than 2, and then you make your print statement. And if we're in Python 3, we should use curly brackets here, actually. Okay, so in terms of comparison between Java, which was more popular, like, let's say 10 to 15 years ago, compared to Python. So Java is, in terms of like superficial differences, Java code is structured using those curly brackets. Every variable is a class, or it's a primitive type, or it's a type primitive or a class. And each piece of code needs to be in a class. And in contrast, Python is not using curly brackets, it's using indentation, which I think makes the code nicer to read and more structured to read. You don't need to specify the type of a variable, so it could change any time during the code, and the interpreter is figuring out itself what kind of type it should have. And you can directly start executing. You don't need to have all those boilerplate, like these public class, etc., public static void around your code, because you can just type it into the interpreter and it will run right away. If you work with lists, let's say our task is we have a list of strings of words, so and we want to lowercase them. So let's say this is our task. Now, if that's a string, it should go in quotations, right? But let's say, okay, here for the sake of illustration, we're leaving away the illustrations, and now let's say we want to lowercase this, so everything should go lowercase, right? If you want to do this in Java, so it could be like this 4-liner, where you define a list where each element in the list is of type string, and you define a variable for it, use those semicolons. Then you iterate over your words. So you iterate over what are you going to iterate. So yeah, so you have your words. So this is your list of words here, up here, and you iterate over those, and the variable, the iteration variable you call this word. There are also other ways to do that. So this is even a fancier way to do it in Java. And then you would add to your list, which you define up here, you would add the word from the original list, and you say, okay, you apply the method to lowercase. So you apply this method and you add this to your list. In Python, you can do this in a one-liner, right? So you make those those list notation here. So this indicates there's a list, and you say, for each word in my words, I do word lower. So I apply the method lower to each word, and you get the output lowercase words. So this is a one-liner. And if you compare this to math, even though this comparison here is not perfectly suitable, because here in math, this is a set and this is a list. So the difference between a list and a set being that a set doesn't have repeated elements. So the the concept of list is more a programming concept. In mathematics, you would have a set, and there you can use a similar notation, right? You go for all W in W, so this is all words in W, and this is the condition, and those things you make lowercase, right? So Python in this from this viewpoint is closer to mathematics. It's more intuitive, and it's a lot less coding in a sense. So that's really, I think you get an impression that Python is intuitive and nice to work with. So let's try it out. A notebook. So we download and install NLTK. So you can do this in Python and in Windows or in Linux or in Mac. And you'll see this in the practice class how to do that. So we've installed NLTK, then we go in the interpreter, we import NLTK. Now we want to download something more, so we want to download the book. The book object in NLTK. So we say NLTK download, then we get a list of things to download. We select book, and then we say, okay, download this book package or this book object. And then it's there. So now we can use it. Now we say from NLTK book. So that's what we've downloaded. Import everything. And we get different corpora. So we have text one. We can type text one, and you see it's an object. With the description that it's Moby Dick by Herman Melville. And there's also text 2 in this book object from NLTK. This is Sense and Sensibility by Jane Austen. Okay, so now we have these two texts. Let's work a little bit with these texts. So we show the context words for each word, which sometimes is also called concordance. So we check text 1 here, and then we say, okay, apply the method concordance for the word monstrous. So we need to give a center word. And so you see the first, so there are like 11 matches for the word monstrous in Herman Melville. And it shows you which words, like here we have 1, 2, 3, 4, 5, 6 words to the left, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and 5 words to the right. So we have 6 words to the left, 5 words to the right. So this shows you the different contexts in which this word monstrous appears. And why can this be useful? Well, you can, like a linguist could go, or if you do an analysis, you could manually check all those contexts, and then you find out how the author, like Herman Melville is the author, right? How he's used this particular word. So maybe if you want to investigate if the word has changed in meaning, right, over time, maybe it's not the same anymore. It doesn't have the same meaning anymore as today. So you could check it by checking the context in which the word appear, right? Because the context somehow is the way we use a word, and the way we use a word is also the meaning of the word. And then you could compare text 1 and text 2. You could say, which are the similar words to monstrous, right? And then we need to find out how similarity is defined in NLTK. So if this were like in modern deep learning, similarity is defined using something that's called word vectors. So each word has a vector that denotes its meaning, and then you can get the neighbors of the word by computing the similarity of those vectors. There are also other ways to do that. So I'm not exactly sure how NLTK is doing this, but you get similar words in this corpus from Herman Melville, right? And it says like similar to the word monstrous is like are these words. So subtly, impalpable, pitiable, curious, imperial, perilous. So these are a lot of adjectives, right? And you can do the same for the other corpus, which is Sense and Sensibility by Jane Austen. And you see like very exceedingly, so heartily, amazingly, extremely. So you get adverbs, right? So and also they are very different, right? The words are very different. I'm not sure if there's any overlap. Doesn't look like, right? So this tells us that those two authors use the word monstrous very differently, even though they are like, it's still a similar time period. So maybe it's like idiosyncratic, maybe it's like peculiar to the particular author how they use those words. We can also do a dispersion plot. So let's say we have another text here. So there's another text 4. We do a dispersion plot, and this dispersion plot shows us the frequencies of the words in different parts of the book. So here on the x-axis, you see the offset. So 0 means this is the beginning of the book, and 20,000 it means like the 20,000th word, etc., or token, right? So this is basically corresponds to where in the book we are. So from the beginning over the middle to the end. And then we can check the occurrences of those words, like citizens. Where does it occur? We see like it's very evenly dispersed all over the book, so it appears like more or less everywhere. Whereas other words like democracy, they don't appear in the beginning and middle, or America doesn't appear very often in the beginning, but quite a lot in the end of the book. So we can really check. So what's happening with words, and what's happening with words is reflecting what's happening to the story and the concept of the book, right? So something changes. Maybe it seems to talk more about America in the end of the book compared to the beginning. Good. So this is the introduction to Foundations of Language Technology. If you have questions, feel free to ask in the tutorial in the practice class on Monday. You can also post questions on Moodle in the discussion forum. And I hope this was like an interesting introduction for you and like gave you some motivation why you want to do this course and why you want to study natural language processing. And yeah, why you want to study language and language combined with computer science. Yeah. So I hope this you got some motivation for that now. So in terms of links for other literature, we have like there's books. So the natural language processing with Python, NLTK. This is the course book. So check it out here. There are books on Python. There are books on linguistics. There are many Python tutorials, NLTK tutorials. So one very important aspect for you is if you don't get along with something, know how to help yourself. So this is a very important aspect for a student, how to help themselves, and you can help yourself by Googling, taking the correct keywords and checking the results that you get from Google or your favorite search engine. Get the results from your search engine and then delve into the results that you get and update yourself. So this is always a very good lesson and a very good ingredient for being successful during your studies and of course also in life. For the next week, you can install Python or the Jupyter Notebook. As you can also ask during the practice class, you can try out the code that we've presented. You can play around yourself, check the slides, go over the slides again. Go read the chapter 1. So this is not a mandatory task, but this certainly will help you, give you additional and more other insights. Explore Python and use the forum to ask questions and exchange with your peers. And with this, our lecture number 1 concludes. And yeah, today you'll get a video for the practice class, and then on Monday you'll have an opportunity to ask questions for the tutors. And see you next time with lecture 2.